Hey guys, welcome back. Today we're looking at exponent rules. This time we're moving on from the power and product stuff to the negative stuff and zero stuff. Um, so let's just jump right into it. I have a table here just to illustrate how these rules work, because if I just told them to you, I know when I first heard them they didn't really make sense. So I kind of like went back and rethought it and figured out how it made the most sense, and this is how we're going to do it today. So we're starting here with powers of 2, and we're going to be looking for patterns here, and it should be pretty straightforward at first. So 2 to the third we know is, I'm going to write in this middle column, 2 times 2 times 2, right? The third power just means we're multiplying it by itself that many times, and we know that's equal to 8. Same with 2 squared, that's 2 times 2. 2 times 2 is 4. 2 to the first, there's just 1 2 there, that's going to be equal to 2. Now we're getting into the parts where we're in an unknown territory, because really, well, 2 to the 0, in my mind, it should be 0, right? But that's not the case. So let's kind of follow the pattern here. So if we're going from one row to the next in this column, what are we doing? Which operation are we doing each time? Okay, so some of us notice that we're dividing by 2 each time, which is exactly correct. So the thing with these tables is they're not going to deviate from that same rule. So if we're trying to find 2 to the 0, we're going to divide 2 by 2 again, but 2 divided by 2 is going to give us 1. Right, so it's really odd. Anything to the 0 power, we want to write this down, anything to the 0 power is 1. Something that you need to remember, right? Because it's going to come up outside of just our Algebra 2 stuff. It's going to come up down the road. Just remember that anything to the 0 power is 1. Now let's continue this pattern. Well, if I divide 1 by 2, then I have a half. And then if I divide a half by half, I get a fourth. And then if I divide 1/4 by 2, I get 1/8. Right, and the cool part about this is, look at this. 2 to the third is 8. 2 to the negative third is 1/8. 2 squared is 4. 2 to the negative 2 is 1/4. 2 to the first is 2. 2 to the negative first is 1/2. Right, so if we're trying to summarize how to do a negative exponent, right, all the negative exponent means to do is reciprocate. So negative exponent means to reciprocate. Okay, if you can remember those things, then today's work should be kind of easy. So let's kind of go through some examples here. Well, the first two are easy, right? Anything to the 0 power is going to be 1. Notice this negative sign is outside of our parentheses, so the 0 applies to the 4/7. We still have that negative left over though. Okay, be careful. Remember, we talked about it last time that the exponent only applies, that's terrible. What did I just write? Only applies to what it's next to. Okay, similarly, let's do our negative exponent. So 2 to the 4th, well, 2 to the negative 4, I know that's the reciprocal, so it's going to be 1 over 2 to the 4th. 2 to the 4th is 16, so this is 1/16. Okay, for number 4, 8 over 9 to the negative 1, I know that's the reciprocal, so I'm going to reciprocate. And to the first power is the same exact thing, so we don't have to really apply the power in this case. Okay, number 5, again, exponents only apply to what it's next to. It's only next to this n, so that's a huge mistake that a lot of people make. 4 stays where it's at. The n is reciprocated, so that drops down into the denominator and then becomes positive. So it's 4 over n to the 5th. Be very careful, it's a very common mistake. All right, next example is u to the 7 times u squared. So what we're going to do is we're going to apply the idea that we did last time, right? We're just going to add because we have the same base. We're going to add the exponents. So negative 7 plus 2 is negative 5. Now let's rewrite this without a negative exponent. So we're taking the reciprocal, which is 1 over u to the 5th. All right, likewise for the next one, but this time let's group all these things first, all the constants. 2 times 6 times 2 is going to be 24. Remember again that the exponents only apply to what it's next to. We don't have any negative exponents on any of those numbers, so they stay where they're at. Let's do our y's. Negative 7 plus 7 is 0, so we're going to have y to the 0. And then we have our v's. Negative 1 plus 7 is 6. And then we have our u to the 9th, and then we have one more u there, so we have u to the 10. Okay, so remember, anything to the 0 power is 1, so that can go away. We don't have any y's anymore, but we have 24, v to the 6, u to the 10. So just applying concepts from last class along with what we're doing today to finish it up. Okay, so we have 2 more pages of examples. They should be straightforward again. The division rule, if you want to use it, and it probably would be good to use it in this case. So the quotient rule, meaning if we have on top and bottom, all we have to do is subtract. So it's like the product rule or the multiplication rule. If we're dividing same base, we just subtract the exponents. So if we're looking at this top one, negative 4 minus negative 2 is negative 2. And then if we rewrite this with a positive exponent, we reciprocate the x squared. Okay, same thing here. So 2 and 6, well, this can reduce, so let's do this. 2 6 is 1/3. A to the 9th minus negative 4 is a to the 13th. Be careful with your signs. B squared minus negative 3 is b to the 5th. And then we have c to the negative 6 on top. It doesn't have anything else to go with, so we'll leave it like that. Now let's rewrite this. Let's make a fraction here though. So we're going to make a big fraction. All the stuff that's positive stays on top. But let's reciprocate that negative 6. Okay, and then that should be your answer. Okay, and then same thing for number 3. This one is a power rule, because we have a power raised to another power, so we're going to multiply. 3 times negative 2 is negative 6, and then we're going to reciprocate. So the key here is we always want our answers with positive exponents for this one. So if you end up with a negative one after you do your calculations, or a negative exponent after you do your calculations, you just reciprocate. Okay, last page. This one's a little bit more complex for a few reasons. So one of the things you could do, if it helps you, is to deal with the negative first. So 3a to the 4th times b to the 3rd times negative 3 to the negative 3rd power. You can reciprocate first if you want to. Some people like to do that. I'm going to do it just straightforward. So we're going to have the 3 to the negative 3. All right, so this is applying again to what it's next to. So it's applying to everything in the parentheses. So negative 3 times 4 is negative 12. And then negative 3 times negative 3 is positive 9. At this point, I know I need to reciprocate these two things because they're negative. So b to the 9th stays where it's at. 3 to the negative 3 drops down. That's going to be 27 when we multiply. 3 times 3 is 9 times 3 again is 27. And then the a to the 12 is going to be positive now that we reciprocated. Okay, so likewise in number 5, there's a lot going on in here. But we're not going to let that get in our way. We're just going to, again, apply that negative 3 to each part in there. So we're going to have x 2 times negative 3 is negative 6. y to the third over 2 to the negative 3, z to the negative 6, right? And then we have this outside part. Okay, and then we need to take this, and reciprocate them. So let's do that now. So we have x to the positive 6 in the bottom. This is going to go to the top, so 2 to the third is 8 on top now. This is also going to go up. Okay, if we put it over 1, that might help, or we can just make it all one fraction. Either way is fine. But this x and this x we're subtracting, right? So we have 8x, 1 minus 6 is negative 5. Then we have y cubed. That doesn't go with anything. So y cubed. And then we have z to the 6th times z to the 5th, which is z to the 11th. The only thing that needs to change here is that negative 5. So that drops down into the denominator. 8y cubed z to the 11th over x to the positive 5. Again, once you get used to it, it gets really fast and really easy. You just got to do a few before you get rolling, and then once you do, then these rules become second nature. But do not forget them, because they are definitely going to show up over and over again in higher levels of math. So if your goal is to get past this, to do college, math in college, or if you have to do math in college for sciences or computer science or any other field like the engineering, then do make sure that you know these rules, because these rules keep popping up again, and there's not going to be someone to re-explain it to you when they pop up. They're going to assume that you know how to do it. All right, so good job today. Write down any questions you have. We can talk about them next class.